which line? So, what you're doing here?
Yeah, it's good.
Good? Okay. Good afternoon. Welcome to MSR6 BOF. Please take your seat, put your chair in upright position, put your phone in your airplane mode, or at least to silent mode, please. Because this session is being recorded and we don't need any musical soundtrack. So we have busy agenda, so I guess we shall start. Yeah, and please scan this beautiful QR code so you are on the blue sheets. So, note well, I guess you've seen it so many times, but I'll keep it on a screen for another few seconds so everyone can read it. It's on the slide deck as well, so you can download it. So, agenda. I'm going to talk for 5 minutes, maybe less. Then we have 45 minutes to talk about requirements and use cases. We are going to talk for a bit about proposed solutions, but I suggest we are not focusing too much on this. And during those parts, please only ask clarifying questions, like I don't understand what you mean by that, and keep questions like I don't think it should be done that way to the second part of the session. We're gonna have open mic discussion, then we'll talk about charter and hopefully make some decisions. Please, because we only have 2 hours and I suspect most people here could talk about on this topic for like a couple of weeks. Please keep your comments focused. And if you notice the first slide, we do not want to talk about how before we discuss should we, right? So what we need to actually agree right now is this problem worth solving? Okay, is it a problem? Do we want to solve it? Do we want to solve it at IETF? And if answer is yes, then where exactly are we going to solve it? Are we going to use existing venue or we need to create a new one? And if you find answer to that question, we can discuss about charter and deliverables and all those things. So please keep this in mind, right? Let's refrain from discussing details of the solution, because if we decide to form a working group, it will be a working group job, not the task of this BOF. So I think, actually, that's all I have. Suresh, any comments?
So just one important thing, like if you're going to join the mic line, please use the Meet Ecolite client if you're local to join the line, so we can kind of manage between the remote and local lines. Thank you very much.
Okay, and the first presentation, let me, MSR use cases, right? Please come here, stay in this pink cross so people, remote people can see you. I will be your voice controlled interface to the slides. Timer? 15.
Yeah.
Thanks.
Kenji, if you want, you can look there.
Yeah.
Okay, good. So, we are like 15 minutes time hour?
No. If you want to look at the slides.
Oh,
when you
okay.
talk.
This is just my
Yeah.
Okay, yeah, we have to put this example in here. Hello, checking. Can you hear me? No, huh? Hello? Oh, yes, no. Okay. Oh. Okay, sure. Good afternoon, everyone. Here, on behalf of the author list, I'm going to talk about the MSR6 use cases. I'm a TNG, And this is some work just is derived based on the mailing alias, the site meeting, and all the contributions from different people. So here I'm presenting. Can you go to the next one?
What? Sorry.
Next slide,
Yeah.
please. Oh, yeah. From the site meeting 112, and also the Melius discussion about the use cases and all the requirement objectives, the team have already laid a solid foundation on what will be achieved, what will be pursued, and all the objectives and requirements. So for the problem statement, so hopefully is you at least you get some background about that things. Here I will just give a some sort of summary on what will be the objective and requirement to be achieved. One is we want to get the first one is the native. So basically, we want this one to be done on the native IPv6. So it's not like in-cap over in-cap over in-cap. The second one is the stateless. So basically, here we do not want to get the gigantic number of software states to be refreshed every some time in the multicast domains, the stateless. The third one is the large scale. So it's like we want to handle a large scale networks, not just like a small. And in the large scale network, we're going to have a numerous multicast streams. And also we have some other requirement like especially what I'm going to, when I mentioned about the technical domain, is some extreme dynamics in the subscriber drawing and the living. And also we want to use the MSR6, this type of a mechanism to get some add-on value and the features that can be coupled together. Okay, so for all the objective and requirements in mind, today I'm going to present 4 cases from different categories. The first one is from the telco domain. It's like a 5G transport network. The second one is from the IDC network for the large scale DC. The third one is for the enterprise network. It's like the vertical is a case for surveillance cameras. The last one is like a holistic use case that it's called SD1, but it's going to span the telco domain network, cloud network, enterprise, and also public. Okay, I can go to the next one. The first use case is the multicast for telco. As we know, with the advancement of 5G technology and its commercial deployment, the multicast communication started to become a challenging issue for mobile operators. 3GPP has already defined in the TS23247 enhanced MBS architecture to handle the different cases. If you look at the top left picture, that is the one in the 23.247. I'm not sure if the font is too small or not, but you can focus on the red circle toward the bottom part of the top left picture. Here you can see the MBUPF and look at there is N3 MB interface is at the very bottom line and toward the left side to the G node B. That is for the multicast communication. If we zoom that one into a large picture, that will be shown at the bottom left. But the bottom left is still a very high-level architecture, like a 30,000-foot bird view of it is a real deployment, but here we just give a very high-level view. So you can see all kind of the ring from the core, from the backbone, from aggregation, from the edge, until the G node B. If you look at the magnitude of order on those type of rings, okay, the ring, you can consider this one is like a multicast tree, but instead of a stick or branch of a tree, here you can consider it like a ring. So each ring corresponding a branch. And then this is just like a chain of rings, but it forms a tree. and rooted on the right-hand side is like a UPF. Okay, and then when you put everything together here, it's on the ballpark around the 30,000 level. Okay, so it's so huge. It's so huge. It's not just so simple to handle this type of things in the regular, or existing solution of multicast. Okay, and remember here, this is for the telco domain. For telco domain and also for 5G, you can consider there are a lot of requirement for the dynamics. Like a mobile subscriber, there are a tendency to move from one G node B to the next one, where 5G has specified the different SSC mode, service at the session continuity mode 1, 2, 3. So for those type of things, you're going to have some anchor PD, the PSA on the UPF side. So this one will introduce another dimension of dynamics. So in that case, even if you try to, you want to do a divide and conquer to put this like a 30,000 node network into some clusters. But the thing here is like, it's going to be very dynamic. It's not an easy job. Maybe you need, I don't know how many CSIEs, but at least something to handle the whole thing. So it's going to introduce the burden of OPEX. Remember, 5G CapEx is already a big burden for mobile operators. So, but put everything together, okay, so you are going to know, okay, what we want to achieve. That is on the bottom right. There's like to avoid poor flow state, to prefer selective over inclusive. Just this one, just you can consider like the DVMRP or the PIM dense mode, those type of things, or worse, the sparse mode. And also we want to avoid unnecessary packet in cap. Okay, this is a telco domain, since is real, and it has a lot of requirements. Okay, including the telco side, the mobile side, and the transport side. Okay, yeah, next one. Next case. Yeah. Okay, this one. No, not this one. The DCN. Yeah. Oh yeah, thank you. This is another case. Is also a real things. Probably you're familiar with the global, the mobile network operator, especially North America or Europe. And then normally they are going to have their own network cloud to run the 4G or even 5G virtualized core. But in mainland China, the mobile operator actually owns both a network cloud and public cloud. Here, public cloud is owned by public hyperscalers. So in those things, we have extremely large DC networks to handle the 5G core network. You can consider, the subscribers in our case. We are the largest mobile subscriber in the world in terms of the numbers. It's like a billion, so about 1 billion subscribers. And then we have some number of DC network to handle the 5G cores. So you can know on ballpark how large it will be. And also there are some other like HPC applications that require the large multicast communication to improve the efficiency. So when you consider this one together, so this is another, we put a number there like 30K switches, layer 3 switches with the links on 60K. So when you put everything together and also consider requirement, we specified at the beginning scalable, stateless, native IP, dynamics, all the kinds together. So this is another challenge use case we have to face. Next. For this one is for the enterprise or the vertical. So this is like the surveillance camera. There are some public stats I found Google. It's like in Beijing, it has like 8 million cameras. In UK, London, it has close to 1 million surveillance cameras. So depending on the government regulation or local governments or policies, so the data captured by those such a large number of cameras will be sent toward some places or some analyzers This is the picture on the left-hand side. So if those information stand towards those analyzers, the amount of information will be very large, and the number of multicast streams will be huge. So for this case, we do not want the network itself to be burdened with the states. So for this particular case, is also a real requirement case. We want to have the host. The host can be the camera or the analyzer to associate together without going through the regular IGMP join, MLD join, those type of things. But this does require the pre-config to associate the host together. Okay. Consider all the three cases, in the telecom network, in the DC network, and also on the enterprise or vertical. So the last case is like a holistic use case with add-on feature and values. We are talking about SD-WAN. SD-WAN itself is nothing new, but here when the skill goes up, this is another real for one large enterprise company in China. It has CPE SD-WAN node up to the nationwide up to 100K CPEs. And those CPEs will be connected through like a telco domain through enterprise, because they have their branch office. And through the cloud, they may have some virtual CPEs running on the public cloud, and those things will be connected through the public internet. So this is really a big, deployment. And remember, when those things are connected together, they go through the public internet. So there is a requirement for the security. You do not want to expose, especially for the enterprise. So in this case, we want to have some sort of way to encrypt. Okay, so remember we have the requirement objective to use the native IPv6. So for MSR6, it's going to have the advantage just to leverage IPv6 extension header, the ESP and the AH header to do this type of encryption. So for this holistic case, you have all the things you want for the scalable, stateless, the native dynamics of MSR6 plus the natural encryption, decryption embedded with the IPv6 extension header. The next one. So the next one is the summary. So here is the use case. The problem statement has been laid down by the colleagues and on the email alias. And
Please finish. We can take the question.
Okay, and here it's just like the summary what we want to achieve. One is the native IP6 is the required, and also the stateless is important. But remember, all things together, we have like the dynamics and some add-on features. So this important things. It has all the objective requirement clearly set up. So yeah, well, hopefully it's hopefully you'll be, you'll get it.
Yeah, thanks. Go ahead with the question.
No,
Greg, your mic is not on, I think.
it's on? No, it's not.
Better?
Yep.
My name's Greg. Can you define what you mean by native IPv6?
Can do what? Sorry?
Can you please define what you mean by native IPv6?
Oh, it's just like using the IPv6 header, using IPv6 header without the encap. It's like.
But are you forwarding on the V6 header itself?
Exactly. Like
The
you
source
can
and
use the native
destination
IPv6.
address?
Yes, and all SRv6, all kind of the native.
But you're replicating. There's nothing replicating in IPv6. You're using an extension, so it's not necessarily native. You have new forwarding information that's really no different than an encapsulation. Putting it in an extension header doesn't make it native. It just relocates it in the header.
Yeah, you can consider, but normally for the native part is we're going to expose the IPv6 header toward the routing side. So when they look at it, it's not looking at some tunnel Okay, there's something, and then decap and find some inside. So that is, you know.
Yeah, go ahead.
Hi, Andrew Alston. Just wearing my operator hat. You referred to non-encapsulated. Now, if you go back to the previous slide, that shows the public internet. That there is, by my reading, a violation of the limited domain as specified in the SRv6 standards. And so I'm trying to understand how you've got a use case there that does clearly violate a current RFC.
Which RFC here? Well, remember here the extension header is something like a proposal, proposed solutions, and the colleagues and will be giving some description of those things. So which after talking about that
in RFC 8754.
I think Andrew, right? Like I think you have a point, but can we have that in the open mic discussion? Because I think
thing.
like the use case itself doesn't violate. Like maybe a proposed solution might violate, like not encapsulating it, but that's a use case. It's a use case, right? So I do get your point, but we can have that in the open mic discussion, right? There's nothing that can be clarified in the.
I'm happy with that.
Okay, thank you.
Okay, thank you.
Stig, go ahead.
Stig Vanas, just a clarification. I hope you can clarify. You talk about the size of the networks, but you didn't say anything about the size of the multicast tree or bandwidth for how many flows you would have in the network. So do you have some thoughts on that?
You want, well, are you talking about the network slicing to divide and conquer to make a large domain into like subdomains?
Yeah. I think Tianji, his question is like, what is the size of the multicast tree?
Yeah.
Not necessarily
the
just
size of
the network.
multicast streams. Yeah. Okay, if you look at the first the use case for telco, and then we have to give the ballpark. Can you go to the telco case? We have to give the ballpark. No. Yes. No. One more. No. Previous. Yeah. Yes, this one. If you look at this one, the bottom left one, and then the ballpark for the NG RAN is running as IP is running IPv6 layer 3. It can up to 30K. Yeah, and then look at all the rings. Like we have like a 10 for backbone, 100 on the aggregation, and for the access on the 1K. So this is like a chain of rings. It's like a tree, but instead of the stick or branch of a tree, each one is just like a ring. And then you like a ring instead of a branch, but those rings will form a big tree.
Right.
Yeah.
But let's say for a specific flow, are you talking about maybe 10 hosts receiving that flow, or are we talking about 30,000 hosts receiving? Or?
Oh, there's a bunch. If you look at it's been discussed in the previous side meeting, that the two IETF meeting ago regarding tip talk. If I remember correctly, the receivers, I think at least 10 million or something. Okay. It's not in my mind right now, but it's about the 10 million level or maybe above.
Okay. Yeah, no, I think it's important to think about, for the solutions or use cases, like if you're talking about small trees to really big trees, just kind of sparse receivers like spread out, or if almost everyone wants to receive.
Yes, receivers spread out, and also remember these are mobile subscribers. They can keep moving among different G node B, and also 5G require SSC service and session continuity.
Tolos, Manakamna, the mic line is closed. Just make a brief statement if you have a
I think we'll
small
way
question.
past the time. I'll answer to the questions raised in my part of the presentation.
Okay, thank you. Okay. Thanks. Manakamna, go ahead.
Yeah, so 10 million receivers, I am assuming they are host, not the endpoints. So tree, they will not participate in actual tree.
Actually, they are viewing the same streams, but on different, if you look at this on different Genobi, on different aggregation, access aggregation, those type of rings. So it's distributed. Remember here, I can see one more thing. This is within a city. It's not on province or state yet.
Okay, perfect. Thank you. Okay. Now we have the remote participants, so please stay here.
Yes, I will.
No, please stay here. There's like more questions.
Oh, they're here.
Yeah, Human, go ahead, please.
Yeah, can you guys hear me?
Yeah, thanks.
Okay, a couple of comments, please. First thing on the 5G use case. As you know, the G node Bs or the E node Bs, they are hosts, so they do IGMP or MLD join to the cell side router, and the cell side router is where the tree starts. So really, you shouldn't be counting the G node Bs or E node Bs because they're just hosts. And for the tree, you should start counting the cell side router because that's where the PIM or MLDP or the tree starts. But my question is that this problem has been solved for centuries. Like all these alerts that you folks get on your cell phone for earthquakes, for bad weather, child abduction, etc., etc. All those stuff are EMBMS and they're multicast. So every single major provider in the world does have multicast running for these EMBMS type of application, which is very important for each government within the world. So that's comment number one. And comment number two is with regard to your camera diagram, if you can go to that one. Or it doesn't matter if you go there or not. But my understanding is based on the multiple smart cities that we have put together, the cameras, they usually do unicast to a server. So there is a server that is recording all these cameras real time, and the cameras do unicast to the server. And the reason that the cameras are doing unicast is because of security. So the camera starts a IPsec tunnel to the server, which the server terminates IPsec tunnel. And any of the operators on different areas within the country that want to look at that stream, they do a join to the server that is recording those cameras. So those cameras are not part of the multicast domain, usually within the smart cities, because of the security issues. They are unicasting to these 4 or 5 data centers that they are recording all these streams live, and then any operator, police, ambulance, whoever that wants to look at those streams, government, they just do a join to the server, not to the camera.
Right, like, but that's a different use case. Right? That's not the use case he's talking about. So, yeah, I think you made your point. Thank you. I think both the points are noted. Thank you. Thanks. Aijan? Aijan, go ahead.
Yeah, can you hear me?
Barely.
Yeah, okay. So I'm Adrian from China Telecom. Here I want to give another example for the multicast requirement from the for a large network.
Arjun, we cannot hear you. Like, can you can you shout or like get closer to the mic or come back? We'll take Wei Chang and then we'll come back to you. Wei Chang, go ahead.
Chuck, could you hear me?
Yeah, go ahead.
Okay, I just would like to provide a little information about the native IPv6. So, as you know, IPv6 traffic in telecom network is increasing rapidly. Cite China Mobile as an example. Our 4G, 5G network, the IPv6 traffic has exceeded 42% till now. In the near future, we will have the opportunity to see the purely IPv6 network. So if we can have a native IPv6 network, there will be a good chance to simplify the network. And the second one about the EMBMS. In fact, in China Mobile, we have already provided the EMBMS services in China. And for the backhaul network, we have to support multicast because the multicast traffic is really big. For 5G, I think that would have the similar requirements.
So, Wei
and
Chiang, I didn't hear a question. Do you have a clarifying question for Tianji, or are you just agreeing with what he said? Because that's what I
yeah,
understood.
I just want to respond. Some people raised the question about the Multicast in 4G EMBMS solution.
Okay.
I
No,
think,
got it. Got it. And we do have time for the discussion, but this is right now for clarifying questions only for this,
yeah,
right?
yeah,
So we can talk about it in the discussion. Thank you.
yeah. Thank you.
Hello?
Yeah, Arjun,
Hello?
Yeah.
go ahead.
Yeah, yeah. Here I want to give another example for the multicast service within the large scale network. Currently the live stream are emerged on the internet service, and I think the large live stream not exist not only within the 5G transport network. It can span the multi-domain. In China, we operate have the several domain several domain connect together. So the multicast source always located in one metro network, and the receiver located in the other side of the metro network. So the live stream will span the multi-domain. So I think such services are solved are currently by the CDN network. I think
Arjun,
in
do you have
future.
a question for Tianji, or you're also agreeing? Because your audio is very poor. If you have a question, please type it in the chat. Otherwise, we'll take it during the discussion time. Like we do have an open mic time.
Okay,
We can talk about it.
Okay, I will type my information within the chat. Okay.
Okay, thank you. Thanks. Thank you, Tianji.
Okay,
Thank you.
sure.
Please, thanks. Yeah, Greg.
Sorry, I didn't catch that was the end of the presentation. It was still up with the slides. This is Greg again. I'm a little baffled that we're not starting with a problem statement, that we're actually looking at a unique set of requirements that can't be solved with existing solutions that are out there to justify some additional work. What we see here is a whole list of use cases that are really not any different than what's already been solved or can be solved by existing solutions. So we've asked this work in the past to provide a problem statement, and we never got one. So I was hoping today we'd actually see some effort to show what the gaps are, what the needs are, and justify this work. And I have not seen it.
I think like you just should wait, Greg, right? Like at the end of this like presentations block, we should get something, and if not, we'll get at it at the charter, right? Because like we cannot,
But
without a problem statement, we cannot charter anything. So I agree with you fully.
Yeah, but I mean, you go into use cases without a problem statement, it just sounds like word salad.
Okay, thank you. Thanks. Nyan, go ahead.
Hello, my name is Gian Mishra. I'm with Verizon, and I'm on this slide deck. What I plan to go over is this state of multicast for USA domestic operators, and then how the from a technological perspective, how the current state of multicast applies to MSR6, and how MSR6 can, at a minimum, meet these base requirements that are used with technologies that are deployed today throughout the United States with operators. Next slide. So from a video transport perspective use cases, we have, and this is just typical distribution. So we have the contribution network where we got uncompressed video. And then from a technology perspective, what's used there is RCPTE, and within the contribution network for seamless and lossless video delivery at the source, as well as at the primary distribution state as well, RSVPTE. At the secondary distribution on the right, secondary distribution network, we have and that's going to the access networks, fixed broadband, and as well as mobile broadband access networks, MLDP, as well as PIM. Next slide. So here we're also sharing the distribution flow from at the very left, showing the uncompressed stream, so the higher bandwidth video delivery at the left, and then it's the primary distribution network, compressed video, and then at the very right, uncompressed video. You know, so the stream of how video flows from left to right, and the technologies used. On the left side, RSVPTE primarily has been used for domestic operators. For the primary distribution as well, RSVPTE, and then as you get to the secondary distribution, it's mostly MLDP for the distribution. Next slide. This slide shows as well similar, and it's showing the distribution structure starting at the very left, contribution. So RSVPTE at the contribution layer, primary distribution, RSVPTE, and then MLDP at the secondary distribution layer, and then out to the access networks, MLDP, and going to enterprises, as well as fixed broadband and mobile broadband. Next slide. This slide shows just a depiction of the public internet, an operator network, in the center showing the core network access aggregation, and then the access network, mobile broadband and fixed broadband. So with the MVPN, PMSI PTAs that are deployed, MLDP is the primary, I would say majority of customers in the US use MLDP and point to multipoint. That's probably the primary PTA that's used. RSVPTE at the source, at the primary contribution network, as well as the primary distribution, and then MLDP point to multipoint. Multipoint to multipoint MLDP is used in the financial industry primarily, and there may be some other smaller use cases, but point to multipoint MLDP is really one of the primary use cases that are used for most customers within the US.
John, can you stay close to the mic because people cannot hear you at the back? Thank you.
Sorry. Thank you. Sorry. And so as far as ASM versus SSM, you know, from a technology perspective, and PIM binder, majority of uses from customer networks, ASM is still widely used on customer networks. There have been a lot of enterprises as well as customers migrating from ASM to SSM. PIM binder is still rarely not used as much with bidirectional trees, point to multipoint P trees within the core. So overall, primarily, it's really MLDP point to multipoint is really the primary technology that's used, you know, for the P tree within the core, out to the from the core to aggregation out to enterprise customers within the United States. Next slide. So this slide shows just private MPLS. So in here, just very similarly, as far as the MVPN use cases for the types of MVPN P trees that are deployed, and it's still primarily MLDP is really the primary, and ASM is still is used primarily for customers, enterprise customers, as well as customers, you know, through provider customers that exist for the other MVPN PTAs that are used. It's not as widely, MDT SAFI and some of the other PTAs are not as widely used. And here in this case as well, multi-point to multi-point for pin binder trees, that is not as widely used. Financial industry is really the primary use case where pin binder is used for multi-point to multi-point trees. Next slide. So this slide shows MSR6 requirements for IPTV video delivery. So here what I'm trying to depict, I guess, is lossless video delivery and fast reroute. That's really one of the primary, primary technologies used for RSVPT. Fast reroute is really a critical requirement for primary distribution, as well as the content distribution networks for, where the source feed comes in. And then as well as with MLDP, multicast only fast reroute. Next slide. Here we're showing as well with MSR6 requirements for legacy technologies, MLDP and RSVPT. So here as well, we're just showing the requirements. So Mpls fast reroute, link node and path protection, 50 millisecond reroute. And then for MLDP, MO, a multicast only fast reroute, as well as local protection. Next slide. So in this slide, what I would like to show is here the preferred choice of transports has been really for operators in the U.S. It's really been between MLDP and RSVPT, and primarily majority of the use cases has been used is MLDP within the secondary distribution networks. The primary distribution and content distribution has been RSVPT for the path protection, and with link node and path protection for disjoint trees, as well as where we're requiring triple play services where you have multiple paths. Next slide. In this slide, what I'm just showing here, and this is just for as far as MSR6 requirements, it's a comparison between MLDP and RSVPT, and just showing the benefits of MLDP, which is really scalability. And as we're looking at as we look at MSR6 and how that is its similarities with RSVPTE, and the scalability, which is important, which MLDP provides, where you can have a single tree with MLDP point to multi-point, where RSVPTE requires N trees, so it's a tree per VPN, so not as scalable. So a requirement that we'll play into MSR6 when we go through the summary of requirements. Next slide. This slide shows as well comparison to the benefit of RSVPTE, and that's really where you have redundant paths, and you need link node and path protection for triple play services, as well as live protection. The use of RSVPTE with that 50 millisecond failover and lossless failover. Next slide. So here as well, we're kind of digging into, so with RSVPTE, the live protection requirement, and with that, being able to have the lossless zero delay failover with live protection, where you have redundant paths, very similar to live, I guess, very similar to DetNet pre-off, where you're having a replicated stream from the ingress to the egress pre-off mechanism, where you're actually sending two streams down to the receiver end. So having that ability and protection with RSVPTE. Next slide. This slide shows the entire, just the overall end-to-end stream, just for going from the left side, from the contribution network, from the source through the distribution, so RSVPTE in the core network and at the distribution layer, and then as you get to the access layer, and then to enterprises and large, medium, small customers, their MLDP primarily used. And then as well, I mentioned there are triple play services. So wherever we have require live protection, use of RSVPTE for path protect, link node and path protection. Next slide. So a summary, so the goal of this slide deck really is try to look at the use cases and really the state of multicast within the U.S. domestic and the requirements that at a minimum that would need to be met by MSR6. And so in summary here, we got fast reroute protection, engineering separate protected paths, scalability, as we see with MLDP as compared to RSVPTE, the live protection, lossless, zero delay, and then lastly, triple play services. Next slide. So this slide, what I wanted to share here is like USA, the state of with USA domestic operators and then SRv6 deployments, and as well as migration towards IPv6. So operators, we understand in the US, you understand the benefits of segment routing and moving towards an IPv6 data plane. However, the deployments have been limited. And here, what I've thrown out in a few bullets, really what the requirements and kind of the benefits of SRv6 over MPLS and reasons why, operators are looking, but we have has not been as widely deployed in the U.S. And just looking at the bullets here that I've got laid out, native SRv6 steering capabilities with SRv6 with an SRH, the benefits of IPv6 flow labels, so having an IPv6 data plane, the gains there, as well as data center deployments where you have you're using an NVO overlay, VXLAN type overlay, IP underlay, where you can take advantage of SRv6 in the underlay, and then IPv6 benefits with QoS, and then lastly MPLS elimination. So there are some gains that USA domestic operators can gain with SRv6 and having an IPv6 data plane. Next slide. So here's the last slide, just a summary of solutions that exist today for multicast, just related to SRv6. So today, MLDP, RCPT, they can be deployed in parallel with our SRv6. We do have segment routing related solutions that can be deployed, such as TreeSID, and then BGP multicast and BGP multicast controller. Those are as well options that exist today that could be deployed with segment routing. And then as well, BIR is available. And then lastly, and just kind of really a segue into the solutions for MSR6 is the new technology that we're going to be going over today in subsequent slide decks. Thank you.
Okay, so we're opening the queue, but please clarifying questions only. If you agree or disagree with the presented cases, we can discuss it during the open mic. Thank you.
Greg, go ahead. Greg Mirsky.
Hi, Greg Mirsky, Ericsson. I have the question about one of your requirements, lossless and zero delay switchover.
Sure.
How you envision to achieve it?
Sure. So I think the lossless and zero delay, that would be achieved with redundant paths, which is something that is deployed today, that you can, with redundant paths where you have a replicated stream.
I
Similar
think, Jan,
to
we are going into the solution space. So I think if I can rephrase your question, Greg, is that a non-negotiable requirement? Would that be a fair phrasing of your question?
Yes.
Okay. All right.
Thank you, Greg.
Okay, thanks. Tom, go ahead.
Hi, Tom Mldp. I was curious really in the sense that I think a lot of the use case for this is obviously going to be in video distribution. A lot of the benefit really from doing this will be in video distribution. I was curious how you envision MSR6 helping with TiVo style services, so pausing live television, for example, pausing live streams and catch up on that. Is the suggestion that we continue falling back to unicast, or do you feel that there's some benefit here that can be made out of a new protocol with regards to that?
I think that as well, that question may be answered as we get into the solution space, but I think with the questions here regarding the requirements, if you could rephrase the question, I think, let's say related to requirements, as we will be talking about solutions, I think, in the subsequent slides.
Can I give a quick answer to that?
Yeah,
sure.
just keep it
So
brief,
we're attempting to restart work on exactly that solution description. We started that in beer, so the stateless options all have ways to improve those solutions, and we haven't put that specifically together for MSR6 right now.
Okay, thank you. Greg, go ahead.
Thank you.
So just trying to understand what you presented here. Like I said, in the absence of a problem statement, what you showed is what the current art is, and your objectives are to be just as good as opposed to gaps that you're trying to solve?
Well, I think in this slide deck, what the goal was to show what's deployed, the state of multicast as it's deployed today, and the requirements that we have today, and then in subsequent solutions that are presented, how these requirements match up, and at least at a minimum, provide those, meet these requirements. So I was actually just laying out the requirements.
So I'm hearing yes. The objective is to be just as good as the existing solution.
Yeah, that's exactly, yes.
So is that an admission then that there's no gap, there's no real problem to solve?
Well, I would say in this deck, I was not actually, the goal of this deck was really to show existing and meeting the requirements and not gaps. I think in the previous slide, I think they were showing some of the gaps, so.
Actually, I didn't see any. It was, again, just all solutions that we have already seen.
Yeah.
So again, so what you're saying here is you have no goals to do better. You don't have gaps from existing deploy to what you're trying to achieve. And your objectives are to be just as good as what we currently have. I don't see any other answer from what you've said and what you've presented.
Thanks, Greg.
Thanks.
I think, yeah.
Yep, understood. Thanks, Greg.
Thank you. Thanks. Tolas, please go ahead. Thanks. I think on the agenda point itself, we are running a little bit late. So like any time is going to cut into the solution, which we are totally fine with. Okay, so just we'll try to get the use cases, requirements, stuff nailed down as much as possible. Thanks.
Okay, welcome. I wanted to get down a little bit from all the details of the use cases to what I'm extracting as the operational use case requirements based on my kind of staying around for 30 years with this technology, multicast, and what I learned from that. Next slide. So I think there's really one core requirement, which is that we want to have a simple IPv6 integrated end-to-end stateless IPv6 multicast for IPv6 only networks. And what IPv6 networks? I think all of them. We saw a lot of them being listed here in the prior slides, but I also think that this technology is quite valuable beyond the large service provider networks, but maybe not for this point in time. I did send notes out to the IoT working groups, which I think should have interest, but maybe another time. Next slide. Okay, so beer has often been more or less implicitly being brought up in the questions raised here. So let's do a quick refresher on what beer and IPv6 networks, how they would go together without new work. So the beer architecture was not specific to any particular encapsulation, but the working group worked on one particular header, which is pretty much, in my view of the world, optimized and designed for MPLS networks to go along with them. So it has all the necessary header elements to support MPLS networks, from the label to the traffic class field for MPLS, the QS, and so on. There's also additional header fields that are not needed in MPLS networks, just in case somebody would want to deploy the same header in a layer 2 forwarding network only. That's, to my experience, mostly stalled because all the people working toward getting that deployed are really interested in MPLS networks. So the solution for supporting native IPv6 only networks that are not running anything else is not to be native IPv6 only networks, but to run the beer forwarding plane hop by hop in parallel to the IPv6 forwarding plane. And that basically, depending on whether you can implement beer hop by hop on every router or just on a few routers, is either 2 layers, or if only some routers are upgraded, you are running end-to-end IPv6 over hop by hop, beer over then hop by hop IPv6 tunnels. So 3 layers of encapsulations. So that is working, quote, in the way fine, as a lot of other technologies we've done is working fine. Next slide. To the end that my experience has been that something really is working for IP multicast when operators want to apply, use, and deploy it successfully, when it is trying to be as close as possible to the unicast technologies that are being deployed in the network. And so I wanted to give some very high-level elements to say that what beer is doing is just not the right solution for a native IPv6 network because it doesn't match these expectations. So we started in '89 with native IPv4 multicast, and by adding that to IP with exactly the same packet headers and as much the same behavior, somewhere we needed to sneak the replication in, of course, we were allowed to reuse and extend the whole ecosystem of IP, and later in the same way of IPv6, starting from the SDKs, the socket APIs, the QS, diffserv, intserv, RSVP, ACLs, all the layer 2 encapsulation that IP headers were built for, IPFix, IPsec, I can go on. I've actually spent part of my career of implementing or architecting a lot of these add-ons to IP, and I'm just really scared of having to do all of this for beer every time that comes around. If we have the option for existing IP networks to have a native IPv6 solution as well, that would allow us to have the same benefits of reusing all these ecosystem elements that we do understand how to build them for IP. We also did try to come up with cool, new, novel multicast routing, MOSPF and DMVPN, and after a couple of years we figured out, well, that's going to be not of fun for the operators, so we had to revert to a multicast technology that is using all the deployed unicast routing protocol just so that multicast became operable. Then basically we had perfectly well working MVPN services for multicast in MPLS networks, which wasn't using MPLS encapsulation, but which was using IP multicast encapsulation. They said, yeah, the customers are buying it, it's fine, but it doesn't meet our operational expectation of our network, which is purely MPLS forwarding plane based. So we spent another 10 years to build native MPLS forwarding plane for those MPLS networks. Well done, total duplication of IP, but that's how the market space works, right? You have people who run native IP networks, and you have people who run what I would call native MPLS networks. And I think in that respect, the beer has kind of evolved over the time that the working group has been trying to be focused to deliver something running really on the MPLS solution. And the proposed draft for this, IPv6 over beer over IPv6 is kind of an add-on that is really not meeting the requirements of native IPv6 networks. Clarifying questions?
Yes. Greg asked already, what is native IP?
Yes, next slide. Thanks for the intro, right? So wait a second, was it the next slide? Go back. Did I go back? Maybe? No? Okay, I'm trying to...
Yeah, I have my homework, my dog ate my homework.
I'm trying to remember which slide it was on. Let me get back to it if it's not... I'm sorry, I'm maybe a little bit confused here. All right. Next slide. No, I'm just trying to remember which slide it was on, right? So the stateless stuff was the other big thing, right? So let's talk about 3 key parts, right? So the most important part is the operational simplicity, troubleshooting, and everything else, where you eliminate a lot of complexity of the stateful. So there's a lot of aspects here in details that I think we can revisit if we had more time in the solution slide. But of course, it was also the core reason for beer. The scale and convergence is where effectively the same applies. And in the solution slides, I think you should see that by going away from what I call the flat bit strings that Beer introduced into, you know, more advanced processable encoding of the destinations or the destination trees, we think that we should be able to achieve a lot better scalability, which we need for the large service provider networks. And that would obviously also be considered to be one of the core requirements. The additional thing that people often forget is that when we want to replicate the ecosystem, we want to get all the way up to the application layer, and that means we need to get into socket APIs. And socket APIs have been extended to support IPv6 extension headers for IPv6 20 years ago with that RFC number that's barely visible on the slide, whereas extensions for other new technologies that we have done would be much, would have to wait another 10 years. That's kind of the minimum time we've seen. Next slide. No, sorry, can you?
I can wait.
I'm kind of, no, you've got the old slide deck. I gave you a new slide deck.
Press refresh. Hold on, that's what I was checking. One comment. Okay, hold on. Let me do something. Go to materials. I need to press this. It doesn't update it. Yeah, not go first.
Okay,
Yeah.
so which one is this one, right?
Yeah.
Let's see. Sorry.
It doesn't automatically
No, that's
refresh
still
even.
1.0. That's still 1.0. I gave you the 1.1.
So that's what we have uploaded, right?
I have 1.1 in front.
So do you want this one?
This one. Go for this.
One.
Yeah, go for that.
Okay. Yeah. Let's try this.
Yes. Okay.
Yeah, go.
Okay, which slide you want?
Wait, can I quickly? Sorry for that. Right. Okay, there we go.
Yeah.
Okay.
Thanks.
That was the slide I was missing. Sorry. Okay. So express diffs over beer, right? So native IPv6 networks means IPv6 networks with or without SRv6. Obviously, the SRv6 networks are the first one that understand the benefit of stateless traffic steering. So they would obviously like to have exactly the same type of stateless traffic steering for the multicast traffic. But in the end, native IPv6 source routing by hop, end-to-end, native IPv6 multicast, hop by hop, and end-to-end. So that basically means on every hop, you're forwarding the packet based on the RFC 8200 rules, including the rules that apply to IP multicast packets, the rules that apply to source routing, and the fact that you're doing that source routing based on a route header with the source routing segments. Like we have two of them for unicast, right? SRH for SRv6, and the other one being the ripple header for the IoT networks. So in the same way, we would have an extension header for multicast source routing that meets exactly the same native IPv6 hop-by-hop routing requirements. I think it's also important to have the day one support for path steering in strict and loose hops, which basically means to be equally efficient in the stack, whether you have support by hop for the technology or only on a few incremental hops, and then you can lose the loose hops. So the more scalable, I mentioned it before, that's the best effort in what we call the traffic engineering path steering solution, the modes. And that's where I mentioned that the flat bit strings have in our simulations been shown to require more copies to be sent to receivers for the same set of especially small receivers things. So I detailed that in one of the solution drafts that we have. And then, of course, very important, as you saw from Guy's slide deck, the integrated support in the header for service guarantees beyond best effort, which so far has been punted off to other working groups. So combining these things is really difficult when you need to do these things hop by hop, and you only have one routing header that actually can be processed hop by hop. So that's why I think it needs to be integrated. And the rest is terminology and a sample picture. Next slide, which is the last slide there. I think the really cool thing that we can do with IPv6 by being something that has been defined all the way end to end is also for these constrained controlled networks like a data center, enterprise, IoT, and other spaces, go all the way up into the host using IPv6 socket APIs. Then the typical use cases you start with are the big data center servers that are routers themselves. So they have all the existing routing requirements to be able to apply the existing technologies. And then there is additional requirements when the hosts are not routers. So that's kind of these last two slides, the two high-level requirements derived from the operational experience and the need to have a native IPv6 network where stateless multicast isn't a second-class citizen by using some, non-IPv6 native technology. I think then there's the Multicast slide at the end. So yeah, right. That's what we would like to have, right? MSR6, keep it simple and make IPv6 multicast great again. So native stateless multicast for all IPv6 networks, stateless IPv6 multicast into applications, data center, industrial, so on, and reuse and share all the good things that Beer has done. All right, thank you. Questions?
Thank you. Okay, thank you. Greg Mirsky. I have one question. Okay, first question is, what is alternative to native IPv6? Because it appears that in your definition in native, you include support IPv6 and a service 6. So
no, I'm saying native IPv6 means forwarding hop by hop on RFC 8200, whether it has an SRv6 extension header or not.
Okay, and then what is opposite to native IP?
Well, if you're not going to do forwarding hop by hop on RFC 8200 rules.
Then what you do?
I don't know. For example, Beer, right? Beer is a different forwarding plane. It could be MPLS. It's a different forwarding plane. If I'm going to do forwarding based on an MPLS header, that's not native IP. If I'm forwarding based on Beer, it's not native RFC 8200 forwarding
But
rules.
then we call it MPLS network. If we
yes.
If we forward on Ethernet, it's Ethernet. If
yes.
we call an MPLS, it's MPLS. It's not native Ethernet. It's not native
that's
MPLS.
Fine, but I think that's why I'm having this picture up. We've used the term native for IPv6 and multicast and so on for a long time to basically recognize that we're doing the forwarding based on that particular forwarding technology.
So it's IPv6 network. Okay,
yes, that's fine.
Then second point is that stateless and simplicity of operation is counter to each other, because it's much easier to debug and troubleshoot stateful network rather than stateless.
That's a statement, and I think we can make votes for that or so, but I think there are people on the other side of that equation as well.
Thanks, Greg. Thanks, Torlos. Thank you. Stig? So a lot of people are not joining the thing, so I'm just like keeping it in my head, so I apologize, but greatly appreciate if you can actually join the app on there. So I have Stig, Tony P, Greg, Joel. That's what's in my head. Thank you.
Yeah, Stig Vanas. Yeah, I'll remember to use that, sorry. So it sounds like this is very simple and just plain old IPv6, but I suspect that, you have to encode new things in the packets, you need to process them, and how you do that processing is very different from IPv6. I know we haven't looked at solutions yet, but...
No, I mean, it is basically a steering header where we need to represent a set of destination or a tree, not necessarily through flat bit strings, but through better encoding for the scalability. It started with with BRTE, me recognizing the scalability issues, but then we did the simulation comparison. So that's one thing. The other thing is the other header elements that we want to make sure, obviously it needs to be native v6. So we need to have the multicast destination address in the header. And then I'm thinking we also want to have the QoS header elements, for example, from what we see we would need in a stateless mode of operation for DetNet. But that's a lot of details that I didn't want to put in the requirements. They are requirements, in my opinion, but I just had them very high level.
Yeah, I suspect that there are some complexities once you start digging into.
Yeah, there are the solution drafts where more of these details are being set. So that's the other section.
You also need a socket API for sending.
Yeah, thank you. Tony P, I don't know if you just went away, but it's fine.
Okay, Joel Halpern from Ericsson. If I hear this claim that somehow this is native IPv6 and somehow that means this is better, one more time I may scream. Doing forwarding is hard. There is a thing called IPv6 forwarding. This thing that you are asking for in this BOF involves representing a tree and involves replicating packets along different branches of the tree, properly processing some different representation. Whether you put that representation in an MPLS stack, in an SRv6 stack that doesn't yet exist, or in an extension header, it is still not the same as current native existing IPv6.
Can you go back for 3 slides and go further back, further, yeah, further, right. So, Joe, we can argue about the native. I think nobody here rejected the term when we were running around for 10 years saying go native for IP multicast, and we called it native IP multicast. So, I'm calling it native IPv6. That's fine. If the discourse gets down to how we call it, let's just call it, RFC 8200 forwarding, which is what IPv6 does, which is what this solution does. It does RFC 8200 forwarding rules. And then basically, no, not all the type of encodings are the same. If you have, IPv6 in beer in IPv6, that is not matching what an I'm still calling it a native IPv6 operator with an IPv6 only network wants to have, right? So that is, why the heck are we having SRv6 stateless source routing if we could have done that with MPLS as well? Thank you very much, right? And that was, of course, not acceptable for operators of native IPv6 networks. They wanted to have a native IPv6 source routing solution for unicast. That's as simple as it goes.
Greg Shepard, representing me. I can't match what Joel went. His emotional level was brilliant. Thank you, Joel. I feel all of that watching this presentation, so much misrepresented of what happened in the beer working group, what happened with this work along the way. But we can go specifically to the host stack, because beer is not a routing protocol. It's a forwarding paradigm. Beer says nothing about IP. Beer says nothing about MPLS. So all this baggage you're hanging on the discussion is a fabrication and misrepresentation at best of what's happened in the other group. But in the host stack, when you say this can't be done, take 20 years, it's been done. I'm not employed currently, and I'm actually unemployable. And after this conversation, I'm probably going to make that concrete. But we had an AWS beer overlay infrastructure 4 years ago, all host-based. So to say it can't be done or it takes 20 years is at best, it lacks imagination, and at worst, it's completely disingenuous.
Greg, can I ask you a question, as beer
Sure.
chair? So can I interpret your answer as beer is kind of open to other kind of encapsulations than what is defined? You don't have to answer it as the chair itself, but do you have any thoughts on?
Oh, I'd love to.
Okay.
Because when this work was first presented, it was presented as transitional. And we made it clear we're not changing the forwarding plane for something transitional when they admitted, the authors, that they wanted to go to native beer. And when that didn't work and get their work actually accepted, we had this whack-a-mole process round. But what I made clear is that an encapsulation sounds great. We're not changing the encoding. The ADs were clear when we had the beer BOF. This is probably not an exact quote from Aaliyah, but the message I got was, don't fuck with a forwarding plane. So we had to get it right. And when you get it right and you cut it in stone, you protect it. And taking those bits and shoving them somewhere else and violating layers and calling it integration, it's not honest discussion. And it doesn't represent good architecture. It doesn't represent the layered architecture that's made all of us successful here. So I'd love to have a technical discussion, but I have yet to be able to maintain a technical discussion on this topic when there's so much disingenuous garbage being flung out, and it just becomes word salad until through attrition, we finally just give up. I'm not giving up.
I don't understand how it is a architectural garbage, or what the other words were that I forgot in your words, when we are having an equivalent, you could say, of a multicast version of an SRv6 routing header for IPv6 packets. So,
which is not markedly different than encapsulating over v6 hop by hop with the next protocol pointer.
no, I mean, it's basically still hop by hop beer RFC 8279 based forwarding rules. There's no reference for the forwarding from, you know, a received beer packet to a sent out beer packet.
It requires a dependency.
Please let me finish.
It's
Needs
a
to apply to,
dependency.
please let me finish the sentence.
And when
Needs
you
to
have,
apply
when
to
you have
other-
an encoding that can stand independent, it can be encapsulated in any way. It makes it flexible for the entire community. When you integrate it and violate layers, you create a dependency.
I can't answer because you didn't let me finish my sentence.
Okay, so just a point of order here. I think we are way over time for like the solution thing. So we need to have the discussions, because I think it's more important that we hear about the problems, requirements, disagreements, and hear about some solutions. So we're cutting all the solution presentations from the agenda and turning this now into an open mic. So queues are open. Everybody makes statements, and told us if you want any other proponents to come join you here, that'll be good as well.
Well, I think everybody from the team can set up. Obviously, the majority is remote, so it would be good if you show
Yeah,
that.
it's queues are open, so it's.
I think one of the important part is to see that obviously we have a strong opposition from the people who want to protect their market segment with what the beer solution has done, whatever is said around that. And so the solution draft intro slides, for example, would list all the vendors, operators, and people that we have seen to support our direction. And I think in the past, and you know, in recent work, many people in the IETF stood up and told me that obviously, you know, when there are differences about interest in solutions, then we just should check if there is a critical mass and support of a particular solution, and if it's technically viable. And then, you know, if a competing solution is there, the same thing applies to it, but not using more or less sham arguments to try to suppress competition. I think that's what I've been seeing here.
Thank you, Antolos.
Maybe perception.
John, go ahead.
Hey, I'm sorry for the non-technical content, but there's two things I need to say. You remember the note well that we all look at the beginning? Do you guys remember the part about addressing each other respectfully?
Yes.
I appreciate that everybody here feels passionately about the subject. I don't appreciate people calling each other's ideas garbage, etc. Please don't do that. Second point, I was really uncomfortable with the cultural appropriation in the graphic on the final slide. I don't know if other people feel that way, but it made me feel bad.
We actually had T-shirts in '95 that we've been handing out, you know, native IP multicast. So I thought it was a reminder of good old times. If good old times has become culturally insensitive, I apologize.
Okay, Tony P. Juniper. So we had this ongoing conversation, you know, because when I look at the solution drafts, it's basically beer packed into, you know, extension header. That's all there is to it when I looked at, you know, what was in the material for this BOF. So
Can I answer to that?
No.
Okay.
Let me maybe, you know, make a statement. So we had this running conversation for 3 years, and I don't think none of the stuff that we said that the process, you know, that was run through resonated much. But that's still, you know, that needs to go into the minutes, okay? So I understand, you know, people are in love with SRv6, okay? I understand some people may already have the stuff in silicon, as was, I think, admitted in the last BOF, all right? And as Jakov said, nothing prevents you to take an IETF standard and do unnatural thing with the stuff and, you know, deploy it. The point of IETF is not to whitewash silicons and not, you know, have people fall in love with technology and just build yet another thing because they love it, okay? The substantial problem I think that you have is that those use cases can be all solved with the stuff is there today, okay? And you better really show a good gap analysis, because then I'm all open, right? But there is no gap analysis. All these use cases can be solved, and we can start to drill the stuff, but it will take too long. Having said that, and we had this conversation, violating layers always sounds like a great idea, okay? But it isn't. The costs later in deployment are insane. If you really care about running this IPv6 native, implement something like beer on Ethernet, and you can send an IPv6 frame over that, over a beer header without or with less overhead than what you try to create here, okay? Doing all these layer violations, as was explained, I think we went through the whole rigmarole at the end when we wrote the technical justification and we laid out what you know, causing with all this stuff. This is most likely violating 6man, and it's clearly violating beer architecture doing that stuff, all right? It stomps probably on 3 different charters of 3 different groups, but you know, it's out my pay range, that's the ADs. So that probably should go into the minutes. Processes have been run. We're like 4th or 5th time at the same place. My point is made. And I don't need an answer because we had this discussion and whatever came back was always the same thing, right? The discussion about encoding the encapsulation took forever, took us nowhere. Thanks.
So, Tony, thank you. So, like, if I summarize your comments, you would want to start with the gap analysis for the existing protocols before you go any further. Would that be a fair summary of what you said?
Yeah, because otherwise, what are we working on? Just another variant because somebody likes it blue rather than red. And, you know, additionally, breaking 7 layers with always, you know, like this, it's more efficient. This is like the first thing I fire my junior developers about, right? If they go to the code and start to make it more efficient, right? So, but I mean, this discussion has been going on for 3 years. So we didn't make any point. Obviously, the parties are pushing the point, but that is for the minutes, you know, as, you know, without any emotions, as the technical layout and someone that cares because this stuff fed me for 30 years and hopefully will feed me for 20 years, right? And I will have to clean up this stuff operationally with people deploying.
Thank you. Tolas, go ahead. And
Yeah,
Greg, Greg, if you can step up to the mic, I think you're first in the line. Okay, so when Tolas answers Tony P's question. Thanks. You're on the mic line.
Yeah. Sorry, it was so much, and I just took the notebook a little bit later, so I may not be able to remember all the points you were trying to raise, right? So now, this is not meant to be beer. This is meant to learn from beer, and it's meant to be what I call a native IPv6 solution. Call it just an RFC 8200 compliant IPv6 network solution. Yeah, I think many people also tried to sell into IPv6 network traffic engineering with MPLS, and IPv6 network operators on the unicast side didn't want to have that. So that's why an RFC 8200 forwarding-based solution was done for traffic steering in unicast, and this is basically you know, one comparable option for multicast, right? And as far as layer violations, no, it's not about the layer violations. It's about the functionality that you get and the operational complexity of having to troubleshoot fundamentally different forwarding planes, right? And I gave the list of functionalities in the ecosystem that are being used in conjunction with IPv4 and IPv6 multicast, that long list that I had there. And if you don't have hop by hop and IPv6 or IPv4 packet header with multicast, then you can't apply these ecosystem functions hop by hop forwarding wise for your packets. And that is what applies to beer. Sorry.
Get Shusong of the... Shusong, go ahead.
Hi, can you hear me well?
Yes, go ahead.
Okay, thank you. Some response to previous comments. The first one is that I think maybe people just remember some arguments or discussions in a beer working group, but the MSR work is very, very beyond what we have done in beer before. And if we go into the solutions, there are multiple different methods of encoding based on source routing. that I think that is not belongs to the scope of beer. And the second point is that IPv6 is not relevant. It's not only one type of encapsulation, and it's not technical preference. IPv6 has its capability of extension, which is more friendly to the host-initiated case, and also more friendly to the flexible encoding we want to support here. So I think these two features are the core of this BOF. So I think people can give more, pay more attention to the solutions, and they will see the benefits there. Thank you.
Okay.
Hi there, Tom Hill from BT. There's a slightly concerning trend of claims that are being made, and they're not just being made within this BOF. Certainly the first two presentations made this claim, but it's being made very far and wide in a lot of standards organizations that operators, such as myself, fully understand the benefits of SRv6. This is very common. At best, that statement is contentious. At worst, it is an outright fabrication. This is not clean cut yet. It definitely is not clean cut. So whenever we get told that lots of people are really interested in this, I don't believe it because I don't see it via any of the other means by which I speak to my peers and the other folks that run networks in an operating fashion around the world. My problem with this is a lot of that has been used as a foundation for what you've presented here today. And my concern is, in doing so, are you starting from the right position? Or are you starting with a poison chalice?
Can I, you tell me when you're done. So, no, I think this is an excellent point, and I was using, so first of all, I've been just fighting for these 30 years just to get, equal treatment for multicast in the networks wherever they are, and not be degraded to a second-class citizen as far as technology service is concerned for the multicast, right? And that basically it was learned from the examples that I said, where we started saying, hey, we think this multicast technology is better. Why don't you just use IPv4 multicast and MPLS network? Works perfectly fine. We don't want to re-implement the stuff for MPLS, and MPLS networks didn't like it. By the way, what are you running, MPLS or IPv6 in your network for the forwarding plane of unicast?
It depends on which network, but okay. For the most part, the main core network is MPLS forwarded, yes.
With respect to SRv6, I don't have any strong opinions, right? I'm just caring for the multicast solution. I think it's important to understand that the way that IPv6, not SRv6 or so, considered to be source routing to be done is with a source routing extension header. We don't have only SRv6, we also have an equal extension header for constrained IoT networks using exactly the same mechanism, some interesting routing detail differences, right? So this is not only proven once, but proven twice. If you don't like it, and you think there's a lot of problems with it, but let me ask you this. Is this a reason that you want to forbid other people who want to have it and want to have an equivalent multicast solution to not get it? Do you think that's the correct prerogative that you have?
What we're asking about here is forming a working group, right?
Yes.
Right. So how much work should be invested in something where one of the foundations of this has been trumped up to seem more important or more useful or better than it is?
Right, but for us on the multicast side, right, it's on one hand using the SRv6 example as the most easy way for people to understand that this is what source routing is doing. The reason for doing stateless multicast is a lot more foundational and a lot stronger in my opinion than for the source routing in unicast SRv6. And a lot of these things can be shown with the benefit that beer gives you in MPLS networks.
I completely appreciate the use case for stateless multicast forwarding. Completely. I also completely appreciate the use case for IPv4 should be a service, and we should be building IPv6 only networks everywhere. It is the long contentious problem that SRv6 has caused within this industry, and to make statements to say that operators really like it is is troubling at the beginning of when the work starts. So we really need to make sure that we don't rely on statements like that.
Right,
We
but
really need to
yeah.
make sure that that we aren't misleading anyone here, in the sense that if there is already a protocol that has problems, we don't want to build on that again.
Yeah, but this is not, I mean, except for the RFC 8200 mechanism of using an extension header in IPv6 as the quote native, however you want to call it, way in IPv6 to do source routing, and then you can have kind of up with your solution, right? If you don't like SRv6, that's fine, but nobody tells you you have to use it. You have to judge, I think, the benefits of the MRH header that we're proposing for stateless multicast based on the benefit of those multicast use cases, right? And so I gave a couple of these things, right? The statelessness as the biggest benefit operationally, and then the new encodings that what we want to do 10 years after we've done them for beer, right? Which was 10 years ago, what's the best we can do? Now we think 10 years later we can do better, right? For those IPv6 network for a longer term solution, right? So there are a lot of technical details that to a good extent would have been in the solution drafts, right? And not only the requirements. There were scale requirements and so on that drive, I think, a significant set of differences. And yeah, the native forwarding is a big important one. I mean, there are all these ecosystem things, right? I've done all these QS thing, diffserv, inserv, ACLs, IPFix, all these things, and it's just terrible to having to repeat that for, let's say, just a beer-based forwarding plane instead of an actual IPv6 forwarding plane that just has source routing added to it. Right? It's the whole bloody ecosystem that you're starting to replicate. It's already hard enough to replicate the ecosystem from unicast to multicast. Believe me, I've done it for all those pieces from unicast addresses to multicast addresses, you know. But now we know it after 20 years having figured that out for multicast. You know, we know how to do it, and the source routing is you know, just complementary for that. So.
Good luck.
Thank you.
Tom. Andrew, go ahead, because you were in line before the other people got on. Thanks.
Thank you. Andrew, Liquid Telecom, wearing that hat, purely that hat. So if I'm going back to the previous point that I was making.
Mike.
Can you hear me now? Is that better? Okay, there we go. So going back to the previous point that I was making, the fact is that that particular use case I was referring to earlier shows SRv6 over the public internet, unencapsulated. That's what the slide showed, right? That is a clear violation of 8754. Clear cut. It's got nothing to do with the solution. Your use case is premised on a violation. And you refer multiple times to 20 years ago, X happened. 20 years ago, we looked at source routing and went, this is a bad idea. And we deprecated it. And the security issues, when you are showing me use cases that are premised on a violation, and then when people say, but it might not be SRv6, but the simple fact is that that's what this is called, MSR6, right? And I also have to second what Tom said, because I keep seeing people saying SRv6, wonderful, everybody's using it here, etc. But there was a slide in the deck earlier that said there is very little deployment in the United States. That's what the slide said. And to me, I read that slide as we came up with something, people aren't using it, now maybe this will get them to use it. This, to me, reminds me of a solution looking for a use case. And I cannot see how that is in the benefit of the industry. I cannot see how that fulfills the IETF mandate of make the internet better. I don't see it.
Thanks, Andrew. So first of all, I don't think we have any kind of, I would call it native multicast. And I think that term has been established by, you know, all these contributors in the IETF 25 years ago. when we started doing PIM. We have very little of that in the internet. The best that we have are kind of research networks, and everything else is in controlled private networks, including service provider access networks to deliver IPTV to their customers and so on, right? So as far as the extent of where multicast today goes and could go with source routing, I think it would be very much the same spaces. And I think that's a great and excellent discussion to have. And if one of those slides was misleading to say it's the random part of the open internet, that's not part of the places where, for example, we have existing multicast solutions that just don't scale and are, you know, harder to operate than the stateless versions, that's fine then. I think there is a mistake in that slide. As far as judging the market space and the set of participants in the IETF that are proactively working toward the solution because they believe in it, I think that's certainly one of the things to figure out. I would just like to understand to what extent people who prefer a different technical solution and all their arguments why their solution is sufficient should have a significant impact in the decision. I think it's secondary. Anything that's technically not working is fine, but you know, if we have competing opinions about market space solution, I think we should just vet for each of them if they're technically solid and if they have enough support in the IETF positively, but not kind of, you know, count the negative against it if it's not technically but based on a different, you know, market solution preference. Mm-hmm. Sure.
For the use case, it's not just like we have MSR6 and then we're looking for some real deployment or something like that. No, it's all the way around. Because especially for the first case for the telco domain, with the advancement of 5G technology and the commercial deployment, and then with some like the TikTok, just like the Chinese version of like Instagram, YouTube, those type of things, social media, and then you are going to see the receivers on the tens millions, maybe, I don't know, it's up to 100 million or not, and also over the 5G network. So we are seeing the problem with that and seeing the dynamic, scalable, those type of things. And then we try to get the, you know, something to handle. It's we're looking at existing scheme solutions, and then we found some discrepancies. And then that's why, you know, this, and also for some other use cases, the same thing. Thank you.
Thank you, Tenji. Yeah, David, go ahead. You show at the bottom of the queue, but you are on the top, so go ahead.
David Lamparter. I'm just going to offer my confusion in case it helps. I came here to a session called Multicast Source Routing, and I feel there's a huge piece missing where there's actually a discussion about how exactly does changing the location of determining the receivers for the multicast group, how does moving that to the source actually help us? How does it, what does this provide? Where is this coming from? I'm seeing like a half solution maybe that is prepared, work in progress, but where did this start? Why is it better? Where is it coming from?
So I had some more detailed solution slides. So when we all started the bio work, right? So what was basically happening is that at that point in time, service providers were saying, hey, you know, this whole multicast stuff is so difficult because we have to troubleshoot multicast state on the P nodes in a service provider network. So, you know, right now we think we have enough bandwidth. We're just doing what we call ingress replication. So you're sending out every packet that enters the service provider as a unicast copy to the egress. And then we said that doesn't scale, right? And we can give you a solution that gets rid of that multicast state on the transit hops, right? And that's basically what beer became. And as I said, in my, you know, evaluation of how the working group evolved is it's just the way it implemented the forwarding plane aspects, especially the encapsulation, very optimized for MPLS networks. And there, I think it's great, right? So, but this all goes back to what we recognized after we did all the MPLS multicast natively for 10 years, and then service provider came back and said, well, thank you for spending 10 years in the IETF on doing MPLS multicast, but now we decided not to deploy it, right? So that's basically one of those, you know, at least my origin story for beer.
okay, but so now I'm asking myself, is this just moving the problem from source discovery to destination discovery? Like, the argument chain is not computing for me. That is what I'm trying to say.
I mean, I'm happy to take it offline. So I think, you know, I don't think this answer fundamentally would be different for beer and MSR6, right? So this is all about, you know, I think high level about the IPv6 networks versus MPLS networks, and then also newer and better encodings of the source routing things, kind of if we break it down to, you know, fundamentals.
Thank you, Tolos. Thank you, David. Yisong, please go ahead. Yisong is remote, Tolos.
Yeah, you hear me? Okay.
Yeah, we can hear you. Go ahead.
Yeah, I'm Yisung Liu from the China Mobile. And as an operator, we have deployed IPv6 more and more. And as introduced in the use cases, we have a very large network and the potential multicast services like the short video live streaming is also very huge. And the existing per flow state solution for the multicast cannot afford the overhead for so huge states for the multicast. And the existing stateless multicast cannot afford the large-scale network topologies. And combine all of these requirements, I think we need a simple and unified solution to solve this, and that can bring a new opportunity for the multicast, I think. So we want to form a new working group. That's all. Thank you.
Thank you. Janbin, go ahead.
Okay, sorry, can you hear me? Hello?
Janbin, you need to speak up. Your volume is really low.
Can you hear me now? Hello?
Yeah, we can hear you, Janbin. Go ahead. Just speak up a bit. Janbin, we'll come back to you. Wei Chang, go ahead. Wei Chang?
Hello? Hi.
Go
Thank
ahead.
you, Chair. Could you hear me?
Yeah, we can hear
Hello?
you. Go ahead.
Okay. So I'm Wu Changcheng from China Mobile. Here I would like to provide 2 points of my observation. The first point, I think IPv6 traffic is increasing rapidly. For example, I just mentioned that China Mobile's 4G and 5G network IPv6 traffic has reached 42%. About 2 years ago, this number was less than 20%. So I think the uh, the uh, the traffic IPv6 purely IPv6 traffic is increasing dramatically. So we have reason to believe that in the near future, almost all traffic will be IPv6. So for operator, we should prepare for the situation. So I think a lot of discussion we have done just now. I think IPv6 native network is a good solution for operator in the near future. And the second point is that the multicast traffic is increasing rapidly, especially some internet live video services, such as TikTok in China, which brings a large number of multicast traffic. But those traffic are currently using unicast solution in telecom network. This has caused a huge waste of bandwidth. And but you know, the existing multicast solution cannot support, cannot solve those kind of issue. So from my point of view, we need to embrace IPv6 and support new multicast service. We need a proper multicast protocol for this situation. I think IETF should prepare for those new requirement, new situation. And as a operators engineer, I suggest IETF consider the new solution, especially friendly for IPv6 on multicast protocol. Thank you.
Renbin?
Okay, can you hear me?
Yes, yes, we can hear you.
Okay. Okay. Now, in fact, because there's no time for the presentation of the solutions, I here just give some this the suggestion about this the solution. In fact, in the solution, it shows. In fact, in the use case, it shows that the BLT is not scale enough to satisfy the requirement and the use cases presented. So, in order to solve this, issue, we in fact we need a solution to combine the SRv6 segment and the bit string to propose a new multicast solution to satisfy this requirement. Because this solution is based on the IPv6, so this in fact there's the new solution cannot covered by CXMAN, Spring, and Beer. So we think we need a new venue to develop the new solution. So this is just a consideration for the MSR both. Okay, that's just some this the thinking about from this the solution, and that's the proposal for the MSR6.
Thank you. Howley?
Yeah, this is Li Hao from S3C. We think MR6 is a meaningful topic as discussed today. I appreciate the presenter clearly defined applicable scenarios for MR6 and its native IPv6 nature. So as a vendor, I believe it will be great to form a complete solution of MR6 and believe that a separate working group is more helpful to promote the process of this matter. Thanks.
Go ahead, Tianji.
Yes. Here I have 4 points to convey here. Basically, it's for the both goals. The first one is just based on the use case, based on the gap analysis that being done before and on the mailing alias. So it's going to say, to answer the question, is it a problem? Is it a real problem? Yes, it is. The second one is well, unfortunately, the technical solutions have no time to be presented, but also those things it's going to show, this is something should be done in IETF, and also it can be done in IETF. For the third point, it's people, from today's participant, today's discussion, and also from the alias discussion, from the side meeting discussion, it show IETF SMEs, subject matter of expert, are showing demonstrate a great amount of interest on the topic. The fourth one actually is is that reasonable to deliver something? Yes, it's actually, if you look at the Sunday hackathon, there's the team just use P4, I think. They did the implementation and the emulation for the MSR6 BE, I think. So basically means it can be done. So for all the four things together, well, I try to answer the question for the both goal. So yeah, we do hope this one MSR6 can be accepted or to be done in the IETF. Thank you.
Okay, I'll abuse my chair power and hijack the queue to relay the message from the chat from Dina Farinacci saying, what does multicast scale? Because receiver state is not tracked. If you require the source to know about the receivers, it's a non-starter. Look at ST2 from mid-80s where source initiated trees failed.
Can I?
Yeah, go ahead, Carlos.
Yeah, so I think one of the core understanding is that in large networks, most of the multicast is sparse. That's why we started with what we call PIM sparse mode, right? So the total number of receivers isn't, the same as the total size of the network. The size of receivers typically is fairly limited, and they're randomly distributed based on the service that you have, and you don't want to have for each of these small groups relative to the size of the network, a state on every hop that you need to troubleshoot. That is one of the core value proposition, exactly what you basically, started doing beer for. And so I think putting this into question would equally put beer into question.
Dino, is it the same topic you're talking about? Okay, please go ahead.
This is Dino. Well, Torlish, your co-author said that they need to support 10,000 receivers. Are we going to put 10,000 receivers in a source route? Give me a break. Okay, so maybe your answer is it's not 10,000 receivers, it's 1,000 receivers made off of 10 routers. Okay, so at that point, the replication has to get to the 10 routers, and then they each replicate to 1,000, maybe over the RAN that supports native multicast. That's achievable, but that's not native multicast. You'd have, if you are sensitive to the native multicast state all over the network for those 10 routers, then you have to use overlays. It's that simple. That's the trade-off.
No, so I mean, the way we're thinking about it, think of a simple service provider core network with whatever number of PEs is the number of destinations that you need to do source routing for, right? And one of the recognition that we had is that obviously it may often be good enough to just have something like 256-bit, which is kind of the most likely standard in beer, and then we get an improvement by a factor of 256 by just sending as many copies as we need to reach all the destinations divided by 256. But obviously, you can now have the easy problem that, especially when you have small groups, you're sending to 10 receivers, but you actually need to send 10 packets. So you didn't have any multicast benefit because you're using flat bit strings. And each of the 10 receivers is in a different bit string. And that's basically what we run for a large service provider topology as simulations to show them. But it's easily understood when you need to break up the receiver space into flat bit strings. So and those things can be done better if you do better than the flat bit string encoding, which would be the next generation of the encodings there.
I think we are
way too much detail.
Yeah, I think so. Yeah, thank you. Thanks, Carlos. Thanks,
Could I
Dino.
respond, or you want me to sit down?
I think sit down would be good. Thank you, Dino. Thank you. Shuru Zhang, please go ahead. I don't know if I got your name right. Please go ahead. Thanks.
Yeah, can you hear me?
Yes, please speak up.
Yeah, here is Zhang Xueru from China Unicom. There have been about 40 smart micro networks and some backbone network nodes built in SRv6 via Unicast. We really need new multicast for large-scale networks, which is based on SRv6 or IPv6. For me, MSR6 may keep the network simple. This is meaningful for the operator. This is we need the use case. Okay, that's all. Thank you.
Thank you. No, we'll get to it. Please, we have some stuff to do. Sujali, please go ahead.
Can you hear me?
I think you have some feedback issues, so if you can type it into the chat, it's probably better. We are really running out of time, so we cannot troubleshoot this. So please just type into the chat. Thank you.
No, is that okay?
You're coming across very low, but please go ahead.
Okay, thank you. I am Sijali from Beijing University of Post and Telecommunications. We would like to make an introduction about our project in open mic, but we didn't have enough time, so we put it in this section, in the discussion, okay? And we had a hackathon plan, a project for MSRBE solution in this IEFT introduction. It mainly includes two parts. The first one is the P4 implementation of MSRBE and the emulations of MSR6BE based on Intel Tofino switches. We have proved the validation of MSR6 based on open source, and we hope to see further progress of this work in IETF. That's all. Thank you for listening.
Thank you. So we just want to have TNG. Did you want to make like a really brief statement on that? Thank you.
First, the mention about the 10,000, 20,000 receivers considered is like unreasonable. Actually, it is. For our first case, and you look at the 5G 23.247, after the definition about the 5 MBS enhanced architecture from the UPF, MBUPF up to GNOB, and you look at that one, that link will be used in multicast, and then the number of GNOB can go like ballpark 30,000 and beyond. So it is reasonable. Thank you.
Thank you. Thank you. So I just want to do like a quick poll of the room, because like I think a lot of the disagreements coming from the problem itself, like not in the solution space, like even though we did talk a little bit about the solution space. So I just want to run a poll, like please get on your phones, computers to raise your hand or not raise your hand based on if you think the problem statement itself is clear. So the problem to be solved is clear. So I'll just run it for another minute or so to figure out what to go next, because we don't want to do things too ahead of like what we have to do. So thanks.
Can I ask, what do you mean by is the problem clear?
Is the problem to be solved clear from like
as in you agree that it is a problem, or that you understand what the statement of the problem is?
Do you understand what the statement of the problem is, right? Like as described by the proponents. Like, so okay. You may or may not agree that's a problem for you to solve, but do you understand what they're trying to solve? Thanks. That's what, and hence the question, right? If you don't believe you understand what's the problem to be solved, then you do not raise your hand, or pick do not raise your hand, which is equivalent to not raising your hand, or raising your hand for not doing it. Another minute. Okay, going once, going twice, poll closed. So we have a very, I would say, evenly split room and like remote room as well. So it's, I think our conclusion as chairs and to be confirmed by the AD is that the problem statement requires further development before we go any further with this, without like, going to a charter or something. I think we need to spend a little bit more time like narrowing down the problem statement, right? And we can continue the discussion on the mailing list and try to make progress over there instead of like trying to go through the working group charter questions, because it does not make sense, right? Because if people don't have a common understanding of the problem, it doesn't make sense for us to ask questions like, do you want to form a working group, right? Because we don't know what you're forming a working group for. So thank you all for coming. we'll continue the problem statement discussions on the mailing list, and I hope to see you in another meeting. Thank you.
Thank you.
It could have been better, could have been worse, right? But I think we need. No, I think it's the thing is like we can speak. The idea of this is not to declare success or failure in this room, right? Like so we get a chance to discuss the meeting. So we can.
What I'm saying is, I just simply don't understand that it's, they don't understand. I simply think we have a very strong position. I'm not sure you're privy to all the history that has happened there.
No, I'm not privy to all the history, right? But I think
I have no idea about history, right? I'm just
right, like so.
Yeah, no, but what I'm saying is, it's an isolated process by claiming you don't understand it. You perfectly understand, but this is the way to reject it.
Correct, right? Like so, I think the way forward, right?
That's exactly we are getting to the point where we had strong enough proof to do the work.
No, that's fine. That's fine. Like so, I think the next step, right? Like,
What I'm saying is,
but it's not going to go away, right? We just delayed by like maybe a week or 2 weeks, right? Because like this charter, like this working group, like there's no rejection of this thing at this point, right? So the idea would be like we kind of define a problem statement and like make it.